Well, this video is for Math 116, and I'm going to go over the sample midterm here. Your test will be very similar to this one. Same number of questions, same types of questions, but different questions. So, page 1 starts out with all this material about functions that we talked about in the first week. So we've got f of x is 5x squared minus x plus 1. And we want to find f of 0.7. And then we want to find f of x plus 2. And we want to simplify the answer in that second one. The first one is just going to be a numerical answer. So, let's see here. So what we want to do is f of 0.7 is going to be 5 times 0.7 squared minus 0.7 plus 1. Pretty straightforward. Let's see what we get here. Minus 0.7 plus 1. And that's going to give us 2.75. Let's see here. Okay. F of x plus 2, 5 times x plus 2 squared minus x plus 2 plus 1. So square that binomial, distribute the negative, and now distribute the 5. 5x squared plus 20x plus 20 minus x minus 1. Okay. So I combined the minus 2 and the positive 1 to get the negative 1 there. So it looks like we're going to get 5x squared plus 19x plus 19. Okay. All right. Next group of problems here, problems 2, 3, and 4. Here we've got function composition and function inverse. So f of x is 5x minus 3, g of x, x plus 1 over 3x plus 2, and h of x, x squared plus 2x plus 5. Problem 2, we want to find h on f of x. Okay, so that means we take the f function and we plug it in anywhere where we see an x. Kind of like that. And then you don't have to do this step. Really what you need to do is plug in the actual function itself and then simplify it. So this is going to be 25x squared minus 30x plus 9, and then plus 10x minus 6 plus 5. So what do we get here? 25x squared minus 30x plus 10x, so minus 20x, and then 9 minus 6 is 3, plus 5 is 8. And there we go. Okay, problem 3. Oh, let's do that over here. F inverse. So we know that y equals 5x minus 3. So we can swap the variables x and y and then get the y by itself. So x plus 3 is 5y. Divide on both sides by 5. And y, you can leave it x plus 3 all over 5. You can split it into 2 pieces, make it decimals. There's lots of things you can do and still be correct. Okay? That's one of the great things about mathematics. All right, problem 4, G inverse. So this, I think, is the trickiest one. So we know that y equals x plus 1 over 3x plus 2. So let's swap the x and y variables. And now we have to get the y by itself. So, remember we want to clear out this denominator, multiply on both sides by 3y plus 2. So those cancel out. Over here, 3xy plus 2x. And now we want to collect the y's together. I'll move the 1 over here, and I'll move this 3xy over here. So what do we get? We get y minus 3xy equals 2x minus 1. And so here's the trick, right? Factor out the y, 1 minus 3x, 2x minus 1, and then divide on both sides by 1 minus 3x. So y, which is our this is h inverse, sorry. H inverse of x is going to be 2x minus 1 over 1 minus 3x. So the two trickiest parts of this are clearing out this denominator, all right, to cancel here, and then this process right here where you factor out the y and then divide through by that to get the y by itself. Okay, so that is page 1. Next is one of these function transformations, problem number 5. Let's see here. I'll do a little sketch of our original function here. Okay, so we start off -7, 5. And let me make a little table here. -7, 5. -3, 5. And then 0, 3. One, 5. And 3, 0. So it goes up and then down. 1, 5, 3, 0. And what do we want? We want to do f of x minus 3 plus 2. So that's going to shift it 3 places to the right and 2 places up. All right? So that first point, -7, 5, is going to go 3 places to the right and be at -4, and then 2 places up, 7. There it is. Same thing here. This will be, the x will be 0, the y will be 7. Oh, there's that first piece right there. This next part, this will be 3, 5. And then 1, 5, so this will be 4, 7. And then this will be 6, 2. Okay, so it wasn't distorted at all, it was just shifted over and then shifted up. So that's it for problem number 5. And let's see what else now. Okay. Now we've got these 4 optimization problems. That's what we've been going over for this past week. Okay? So for these problems, I'm asking you, when you take the test, to do 2 out of the 4 problems. That's it. Okay? Don't do all of them and then expect me to pick out the best one. I don't do that. Okay? I grade the first 2 that you do. Right? So pick 2, do those 2, and then be done with it. If you do another problem and don't want me to grade it, say that right on your page. Don't grade this one. Okay. Anyway, I'm going to go over all 4 of the problems just so that everyone can see how to do these problems. All right, for all 4 of them. So problem 6, we've got our distance formula. All right, and what do we have here? I've got a function y equals x squared plus 3. Looks something like that. Oh, x squared plus 3. And we want to find the distance between a point on the curve, xy, and the point of 4, 2. So that's going to be kind of out here somewhere, 4, 2. And we want to find the closest point on the curve to the point 4, 2. So, let's see. So our distance then is going to be the square root of x minus 4 all squared plus y minus 2 all squared. But then, remember, we want to express this as a function of x, so we're going to replace that y with x squared plus 3. And so, x minus 4 all squared plus x squared plus 1 all squared. There's our function. Use the graph to determine the point that is closest. How far away is it? Okay. Part B, we're going to get x and y values. And in part C, we're going to put the distance in there. All right. So, let's see here. X minus 4 all squared. X squared plus 1 all squared. And that ought to do it. So let's look in the standard window, see what it looks like. Something along these lines. So our minimum is going to be right in there. Let's go in and find out what that is. So the x is 0. Let's see, did I put any rounding on here? Nearest hundredth. So this is going to be 0.88 on the x. And then if we do, darn, I lost the distance before I exited out to calculate the y. And actually the calculator will calculate y for you. This is, I'd have to enter it. All right, the d is 3.59. So that's this distance right here, 3.59. This x is 0.88. And now I'm going to calculate that y coordinate right there by doing 0.88 squared plus 3. That gives me 3.77 on the y. And there we go. Okay. That's problem 6. I'm going to erase this because it's on the video. You can just back it up if you need to see it. Okay, problem 7. A storage container, rectangular base. All right, so this is not a square base, it's a rectangular base. No top, and the volume is 12 cubic meters. Height is to be 3 times the width. So if I call this x, then the height will be 3x. And we can just call that L. Okay, let's see here. So, first off, we need to know about the surface area here. So the base is going to be L times x, right? There's no top. We don't have to worry about that. You've got a side here and a side here, so 2 of those are x by 3x. And then the front and the back, 2 of those are L times 3x. Okay? Let's see. The base is $15 per square meter. And then all of the sides are going to be 8. So this is going to be 6x squared, 6xl. Okay. All right. Now, and I normally make this substitution actually before I plug in the cost pieces, but it doesn't really matter. So our volume here is L times x times 3x, which is 3x squared. L equals 12. So L is 12 over 3x squared, or 4 over x squared. And that's what we're going to substitute in right here and right there for the L. So this is our cost function now. So that's going to be 15x times 4 over x squared, and then 8, 6x squared, 6x times 4 over x squared. All right, what do we got here? This is kind of a mess. This is going to cancel one of those, and that'll give us 60 over x. This is just going to be 48x squared. And then over here, let's see, this x cancels out one of those x's. And then we're going to get 48 times that 4 up there. What is that going to be? 160 and 32. Is that 192? Let me double check that. 192. Okay. So 192 over x. We can actually combine these two if we want to. That would be 252. So I'm going to use a cost function here. 48x squared plus 252 over x. Okay, so let's go ahead and graph this. 48x squared plus 252 over x. Let's see, let's look in the table here. I'll make my y maximum 300. And my x maximum doesn't need to be very big. I'm going to make it 5. So, and I made those decisions by looking in the table. Really, what we're looking at is something like this. For most of these problems, you really only need to look in the first quadrant. Okay? And this is just barely enough to see that little tiny loop right there. Maybe I'll push my y up to 350 so you can see a little bit more of it. Okay, so there's our minimum right there. Let's go in and find out what it is. X is 1.38. And our cost is going to be 274.02. All right, let's see if we answered the questions. Find the dimensions of the box that will minimize the cost. That's all we needed. Okay, so we know x is 1.38. So 1.38 times 3 is 4.14. And then the length is going to be 4 divided by 1.38 squared, 2.1. And there it is. Okay. So that's problem 7. Again, I'm just going to erase all this, and if you want to take a look at it again, you can back the video up, but I need the space. Okay, let's see here. Problem 8. At noon, ship A is 250 miles due west of ship ship B. 250 miles. Ship A is sailing east at 25 miles per hour. Ship B is sailing north at 15 miles per hour. Write an expression that represents the distance between the two ships in terms of t. So here's our distance right here. That's a right triangle. So this side for B is just going to be 15t. But this one here is going to be 250 minus 25t. Right, because it's getting smaller as time goes on. It starts at 250, and then it's 225, 200, 175, and so on. Okay? So our distance then is going to be the square root of 250 minus 25t all squared plus 15t all squared. All right, so there's our function, and now we just need to graph it. So square root 250 minus 25x all squared plus 15x parentheses all squared. And let's see, they're starting at 250. Let's make my y maximum. I'll make it 300 again. And the x maximum, let's look at 12 hours and see what happens then. Yeah. So that's going to be a pretty good window. Let's see, I think this was 300. And so that gives us a graph, does something like this. So there's our minimum right there. That's what we're interested in. So let's go in and find out where that is. Okay, 7.35. So T is 7.35 hours, and the distance there is 128.6. Oops. 128.6 miles. So there's one answer. This expression is first thing I asked for. And then to the nearest minute, what time are the ships closest to each other? So that's going to be 7 p.m. And then we got to do that 0.35 times 60, 7:21. 7:21 p.m. And there we go. That's problem 8. Okay. One more. Remember, you only have to do 2 out of these 4 problems. So pick the 2 that seem like they're the best for you, and then you can plan to do those ones on the test. All right, problem 9. We've got this handy little diagram. The street, that is 30 feet. Then down here, 40 feet. This is the water line. And then over here is a hydrant. And, all right, so cost of construction is $40 per foot under the pavement and $20 per foot under the ground next to the road. Okay, so this is where we want to set this up, where this is going to cut the diagonal somewhere. We'll call that x, and that one 40 minus x. And then this length right here, that distance is going to be the square root of x squared plus 30 squared. Okay? All right. So our cost on this one is $40 per foot, and on the other one, $20 per foot. So our cost is going to be 40 square root x squared plus 900 plus 20 times 40 minus x. All right, so let's go ahead and graph that. So 40 square root x squared plus 900 plus 20 times 40 minus x. And let's see, 2,000. Let's see what that looks like if I make my y maximum 2,000. And my x maximum is going to be 40. X can't be any bigger than 40, and it really can't be any smaller than 0. Yeah, that's what I suspected was going to happen if I made the maximum 2,000. It puts the curve way, way up at the top. Let's change that and make my y maximum 2,500. That'll give us a little bit better look at the curve. And this goes out to 40. And then we've got this kind of shallow curve right here. Somewhere in the middle there, we're going to get a minimum. So let's go ahead and find that minimum value. X is 17.32. Let's see here. Find the minimum cost. That's all I'm asking, minimum cost. $1,839.23. So $1,839. $1,839. And that's all the question asks for. All that other stuff, how much is going to be, you know, how long is this, how long is this? I didn't ask that in the question. Sometimes you might have to find that out, but in this case you didn't. All I asked for was this value to the nearest dollar. Okay, so that's it for the midterm. I'm going to have your first project ready to go next week. I will send that out, and then we will get started on the second half of the course. As always, if you have any questions, please let me know. Thanks.